Today we are going to look at this power supply. This is a 48 volts. It claims it can do 600 watts. And this is aimed for use for TPA3255 board. This is sold by Lucia Technology. So this is the spec of the board. Okay, so it's a 600 watt peak, rated 400 watts, 180 to 230 volts input. So this is the board, this is the output, this is the positive, negative, and this is the AC primary input. Let's look at the primary side. So we have an X capacitor here, we have a fusible resistor here, and common mode choke, another X capacitor. There is no Y capacitor, and we have an NTC here, and then we have our bridge rectifier. We have a small MLCC capacitor, and we have our main filter capacitor here. Then we have our driver here. So where is the control chip? Okay, so it looks like the control chip is down here. We have two of them. We have an optocoupler here. So the heatsink here is just being held by the two driver here. It's not being screwed to the board. You can see it's moving. Also this one here. First, let's look at the on voltage of the power supply. Okay, so we're going to capture what is the turn on voltage of this power supply. So we're going to do a single capture on our scope here. So I'm just going to press this one, single. We need to wait for this to get ready. Okay, so now it's ready. We have 2 seconds on our horizontal control here. 2 seconds. Okay, so I'm gonna plug the power supply now. So let's wait for, okay, so our setting is 10 volts, so its division is 10 volts. So this is 10, 20, 30, 40, 50. So the output is around 50 volt, and the output of the power supply is not regular, is jumping up and down because there is no load. So you can see here the output is not stable. Supposedly 48 volts, so let's try to put a small load on the power supply, 50 milliampere. So with a little bit of load, the output voltage of the power supply stays around 48 volts. This is a 1 ampere ripple. We have 1 ampere here. So this is the ripple of the power supply at 1 ampere. You can see it here. Now let's look at the efficiency of the power supply at 1 ampere load. So we have 1 ampere, 48 watts output, and it's pulling around 55 watts. So that is 48 divided 55. So around 87% efficiency at 48 watts output. Now we're going to look at the ripple at 2 amperes. By the way, I have a fan here pushing air directly to the heatsink of the power supply to help it cool down. Okay, so we have 2 amperes, 96 watts. Let's look at the ripple around 300 millivolts peak to peak. Let's look at the efficiency at 2 amperes. We have 106 watts here, so that is 96 divide 106. So around 90% efficiency. Now let's look at the ripple of the power supply at 4 amperes. Okay, that is 4 amperes, 192 watts. So that is the ripple here. Up to 400 volts, millivolt, peak to peak. So that is 192 watts. Let's look at the efficiency. It's pulling 209 watts here. So that is 192 divide 209. Okay, 91.8% efficient at 4 amperes. That is 4 amperes. Now let's do 8 amperes and let's look at the ripple of the power supply at 8 amperes. I hope this power supply does not blow up. Okay, that is 8 amperes, 382 watts. Looks like our AC power source has tripped. So let me reset this for a few minutes. Okay, so I've reset our AC power source. Let's turn the electronic load. That is 4 amperes. We want 8 amperes. Okay, that is 8 amperes, 382 watts. Let's look at the ripple. 460 volts, millivolt plus. 460 millivolts plus. Peak to peak. That is 382. And it's pulling 419 here. Let's look at the efficiency of the power supply at this load. 382 by 419. So that is 91% efficient at this load. Okay, so the electronic load is making a racket now. It looks like it's going into so I'm going to turn off the electronic load now because it's almost at its limit at 400 watts. Let's wait for a little bit for the electronic load to cool down, and we'll do 8.3 amp. That is 400 watts. Okay, let's do 8.3. Okay, that is 8.3, 396 watts, 397 watts. So this power supply can deliver 400 watts. So it's just short, 3 watts short to 400 watts. This electronic load can only do 400 watts. So it's the most we can do. Maybe if I push it at 400 watts, we're going to damage it so I'm not going to push it exactly at 400 watts. So it's pulling 435 watts here. Let's look at the efficiency. That is 397 watts, 397 divide 435. And that is still the same, 91% efficient. 397 by 435. That is 435. 91% efficiency. And the ripple, this is 480 millivolts peak to peak. Okay, so that's it for today for this power supply. Thank you for watching. Please subscribe to the channel.